All right, boys and girls, welcome back to SAT Countdown Reviews, and today we're going to discuss a bit more geometry. Yesterday, day 10 rather, we started with lines and angles, and today we're going to discuss triangles. Now, triangles are a very interesting topic. There's a bunch of questions about triangles in the SATs, and it can get a little tricky, but if we solve enough problems, we shouldn't have any issues. So after every subsection of this video, I'll briefly explain, maybe a minute or two, a few important things, rather than explaining, it will be a bit of a review, quick review, and then I'll move into solving some problems because we're getting very close to the exam. Okay, we need to do a lot of problems, and make sure you pause the video before the problem set and then do it for yourself. And then check out my solution, because sometimes you might find out that either your method is better or mine is better, but it doesn't matter whose method is better. Whichever one is faster, that's the one you should go with. Okay, so the first thing we're going to discuss is going to be a few important rules. I'm sure you're familiar with most of them, but the first one is going to be angle sum theorem. We don't need to remember that this is a theorem, but we do need to remember the rule. So the rule is the internal angles of a triangle always adds up to 180 degrees. So angle A plus angle B, plus angle C is going to be equal to 180 degrees. Okay, the second thing we're going to look at is the exterior angle theorem. And what this one says is the angle BCD, which is the exterior angle of angle C, is going to be equal to angle A plus angle B. Okay, angle A plus angle B. In the triangle above, what is the value of x? What is the value of x? Now, we have two internal angles kind of given. I know one of them is x, unknown, we need to find that. And we have one external angle. Now, from the external angle theorem that we just discussed, we know that x plus 48 has to be equal to 3x minus 40, right? So we can move the x's to one side and numbers to the other side. So I'll move the 3x here and number to this side. So I'll have negative 3x plus x is going to be equal to negative 40 minus negative 48, so minus 48. And this is going to be negative 2x equal to negative 88. And divide both sides by negative 2x is going to be 44. In the triangle ABC above, if AB is equal to AD, so I'll just put these lines here. So these two are equal, and they're also equal to DC. What is the value of x? Now, this is a very good example for isosceles triangles, meaning the triangles with the equal sides. So we know that if we're looking at ABD, triangle ABD, what do we know about triangle ABD? We know that AB is equal to AD, which means what? Which means angle B is going to be equal to angle D. Okay, so these base angles, in this case BD is the base, they're equal to each other. But we also know AD and DC are equal to each other. AD and DC are equal to each other, which means this one and this one is also going to be equal to each other. Okay, we know one of them is 18. And we're looking for value x. Okay, so let's build it up slowly. Now, we know this is 18, angle C is 18. If this is 18, this is also going to be 18 because the sides are equal, okay? Then this angle right here, angle D, or rather ADB, angle ADB, according to the external angle theorem, is going to be equal to angle A plus angle C, okay? And that's equal to 18 plus 18, which is 36. So this is 36. Now, we said that B is equal to this D angle, which is also going to be 36, right? Then we can find x from here. We know the internal angles should add up to 180 degrees. So x plus 36 should be equal to 180. X is going to be 180 minus 72. And that's going to be, what is that going to be? 108. 108, so the answer is going to be D. In the figure above, AC is perpendicular to BC. What is the measure of angle ABC? Angle ABC. So we're looking for this one right here. This angle right here. Okay, we know this is 55. Good. We know this angle here is 30. We know this is 30. So if that is 30, the complementary, or supplementary rather, supplementary angle to this is going to be what? So let's call this one D. Let's give, I don't know, F here. So angle F D B is going to be 180 minus 30, which is 150. Yes, because it's a supplementary angle to the 30 degrees. And we know, what else do we know? What else do we know? We know that angle F, let's call it DFC, plus angle FD, FDB, plus angle DBC, plus angle C, they should add up to 360 because it's a four-sided shape. Okay. So which one do we know? We know DFC. Do we know DFC? Yes, that's 55. We know FDB, which is 150. DBC, we don't know. That's going to be our X. And angle C, we know it's 90 degrees. So that's equal to 360. I just went off the screen. Equal to 360. So we can find X from here. X is going to be equal to 360 minus whatever this thing is. I think 295. And that's going to be 65. So the answer is going to be D. In the figure above, if AD equal to BD, and that's equal to 2 square root of 3, what is the length of AB? What's the length of AB? So what do we know? We know this is 30 degrees, and we know these sides are equal, which means this is also 30 degrees, right? So if that's 30 degree, this is 30 degree, then this is going to be, by the external angles theorem, this is going to be 60 degree, and this part right here is going to be 30 degrees. So we just found all the angles that we need. Okay, so what are we dealing here with? We're dealing with this triangle, the small one, ACD, A, C, and D. This is 60, and this is 30. So we know this is 2 square root of 3. Okay, again, if the hypotenuse is 2 square root of 3, then the angle in front of 30 degrees is going to be what? 2 less than that, which is square root of 3. And the other one is going to be square root of 3 times square root of 3. Again, based on the rule I just discussed. If you missed that, maybe go back and review that one more time. So meaning this is going to be just 3. Okay, what's the length of AB? Now, let's see what we have. We know AC is equal to 3. We know CB is equal to what? Square root of 3 plus 2 square root of 3. Yes, which is 3 square root of 3. Fair enough. And then, what else do we know? I think that's all we need. To find AB, we can use the hypotenuse, the Pythagorean theorem. So AB square, this is B, is equal to AC square plus CB square, which is going to be 9 plus 9 times 3. That's a square of this. Okay, that's going to be 9 plus 27, which is 36. So AB squared is equal to 36. That means AB is going to be equal to square root of 36, which is just 6. So the answer is going to be C. In the ABC above, BD is equal to 3. What's the perimeter of angle ABC? So again, before I start doing anything, I see some angles, which means I can probably find the remaining ones. So if this is, the C is 60 degrees, that means this is going to be 30, right? So this one is 90. 30, 90, that's 120, so this is going to be 60 degrees as well. So now we're going to use that 30, 60, 90 angle stuff. So what do I know? I see that the side in front, the BD, which is in front of 30 degrees, this one right here, is equal to square root of 3, which means the hypotenuse is going to be 2 times that, and AD is going to be square root of 3 times square root of 3. Okay? So, what else do I know? For the other triangle, CBD, if the angle, sorry, not side in front of 60 degree angle is square root of 3, that means we took DC and we multiplied it with square root of 3, and that gave us square root of 3. Right? Take a moment to think through it, yes? And which means DC is going to be 1. So this is 1. And with the same rule, the hypotenuse is going to be 2 times that. So BC is going to be 2. We're looking for a perimeter here. So AB plus BC plus AC. That's going to be equal to 2 square root of 3 plus 2 plus 1 plus 3. This is AC. Okay, so 2 square root of 3 plus, what is it, 6? 2 square root of 3 plus 6. So the answer is going to be B. Now we're going to look at the similarity of triangles. Now there's some rules that we can remember. So if we have two similar triangles, the angles are going to be the same. You can see the angle A is equal to angle D and angle B is equal to angle E. This sign here means they're equal because of the similarity, and then angle C is equal to angle F. Therefore, the triangle ABC is similar. This tilde sign means similar to angle DEF, and we have some proportions here. So AB divided by DE is equal to BC divided by EF, AC divided by DF, etc., etc. So their areas will be proportional, their perimeters will be proportional, the angles will be the same, and the sides will be proportional. Okay. So let's solve some problems here. In the figure above, if AB is equal to 6, DE is equal to 3, and the BD is equal to 12, what's the length of AE? Now, I see that I have two triangles here. So the triangle ABC, which is a right angle triangle, and triangle CDE. That's also a right angle triangle. This is triangle sign. That's also a right angle triangle. Let me delete that actually. Try one more time. There you go. They're both right angle triangle, though that's not enough for similarity. We also see that these angles are adjacent angles, meaning they're equal to each other. So which means we have two angles that are same, which means the third one will also be the same. That means we can safely assume that these two are similar triangles. What is the length of AE? Now, to find AE, we don't really have enough information just yet, but we can get there. So, based on the proportion rules that we just looked at, AB divided by DE has to be equal to what? We know what BD is actually, which is 12. It should be in the same proportion of BC, this is BC over CD. Okay, so AB over DE is what? 6 over 3 is equal to BC over CD, which is just 2, right? So BC is equal to 2 times CD. So BC is twice the length of CD. And we have 12 here, which means we have to divide it into 2 parts, where one part is twice the size of the another part. So I can divide it by 8 and 4. Good. Now I have 2 triangles with 2 sides, which means I can find the hypotenuse for both of them. Now, if we do Pythagorean theorem for the first one, that's going to be 6 squared plus 8 squared equal to AC squared. And we can find that out. AC is going to be square root of 100, which is 10. So AC is 10. And second one, 4 squared plus 3 squared is going to be equal to CE squared. And from here, CE is going to be equal to square root of 25, which is going to be 5. So CE is 5, AC is 10, which means AE is going to be the sum of them. So 10 plus 5, that's going to be 15. All right, next one. In the figure above, angle B is similar to, angle B is similar to angle D, or same. If BC is equal to 16, CD is equal to 10, CE is equal to 11, what's the length of AE? Now that one is pretty simple. If we can find what AC is, we can find AE, because AE is just AC plus CE. Yes? So, what do we have here? What do we have here? What's the length of AE? So we see that these angles are adjacent, meaning they're equal to each other, and B and D are also equal to each other, which means these triangles are same, which means we can use the proportion stuff here. So we can say, for example, CD divided by BC has to be equal to CE divided by AC. Yes? Now, that means CD is how much? CD is 10, BC is 16, and C is 11, AC is whatever AC is. We don't know what AC is. So AC is going to be equal to 11 times 16 divided by 10, which is going to be, I want to say 176 divided by 10, and that's going to be 17.6. Now, I do notice that it says what's the length of AE, but AE is supposed to be AC plus CE. So that should be 17.6 plus 11. But I think there's a mistake here somewhere in the question, because we don't really have that. We don't have 17.6 plus 11, which should be 28.6. So I think what they're looking for actually is AC. AC, based on these answers. Or if they're looking for AE, they don't have the correct one. So the answer is going to be 17.6, assuming this is, they're looking for AC. In the figure above, what is, the area of the right triangle is 60. What is the perimeter of angle ABC? Now, that's a common type of question. We're only given one side, which is the base, and nothing else. But we know the area is 60. So area is equal to 1 over 2 base times height. Now, in this case, base is 15. Height, we don't know, and the area is equal to 60. Now, do a little algebra. Multiply everything by 2. 120 is equal to 15h, and h is going to be equal to 8. We're not done, because they're asking for a perimeter of ABC. We know this is 8, this is 15, so AB, based on the Pythagorean theorem, is, well, let me write it that actually, equals to 8 square plus 15 square. That's going to be, if I'm not mistaken, 64 plus 225, it's 289. That's going to be just 17. We're lucky we got a good number here. So the answer, perimeter, is equal to 8 plus 15 plus 17. And that's going to be 23 plus 17, which is 40. In the triangle ABC above, if BD was increased by 50% and AC was reduced by 50%, how would the area of a triangle would change? Now, that's a very interesting question. It sounds a bit complicated, but it can actually be solved very quickly. So we know the area of triangle is equal to 1 over 2, right? Base times height, or BH divided by 2. Okay, now I think the easiest way to do it is actually to give them random numbers. Okay, it doesn't really matter, but since we're dealing with 50% increase and decrease, I'll pick a number that's divisible by 2. So I'll say, for example, B is equal to 4 and H is equal to 4. Again, it doesn't matter. So the area for this, A1 let's call it, is going to be 4 times 4 divided by 2, which is going to be 16 divided by 2, 8. Okay, now what does it say? It says one of them increased by 50%, other one decreased by 50%. So if we increase 4 by 50%, it will become 6, right? If we decrease 4 by 50%, it will become 2. So 6 times 2 divided by 2 is going to be just 6. Now what happened to our area? It was 8 before, now it's 6. So how did that change? It definitely changed. Did it increase or decrease? Definitely decreased. So B is not the answer. Would not change is not the answer. The area of ABC would be decreased by 25. So either 25 or 50%. So if 8 decreased 50%, what would that become? 4. You're right. It will become 4. So it decreased only 25%. So 25% means 1/4 of the value. So 1/4 of 8 is 2. So 8 minus 2 is equal to, so 8 minus 1/4 of 8 is going to be 8 minus 2, which is 6. So the answer is going to be A, decreased by 25%. All right, that concludes today's session. Hopefully you guys did learned something today. Tune in for tomorrow's video. I'll discuss, I think, circles, and then we'll have another discussion about surface areas and volumes. Okay, make sure you check them out as well. If you have any questions, please do let me know. If there's anything you want to see in these videos to be covered, please do let me know them as well. But until next one, take care. Make sure you practice a lot. Exam is coming up very soon. Have a good one. Bye bye.